So, here we are going to discuss about heat pipe demonstration apparatus, correct. So, as you can see here we are having 3 pipes, something it is, I will explain about that. You can see all the panel, boards, everything is there. There we are having one connection at the point, okay, from the mains we are getting that power. Next, first of all, what is the need of this one? As we know that the heat can be transferred from one point to another point. While transferring the heat from one point to another point, how the process takes place, okay? How we can transfer the heat from higher temperature side to lower temperature side. The same thing we are going to demonstrate here. What it will do? It will help us to identify the heat flux that is generated at the higher end and that is getting transferred at the lower temperature end, okay? Higher temperature end to lower temperature end, correct? So, let us see what we are having in this apparatus. First of all, we have 3 systems, or you can say 3 pipes, in which first one consists of a copper rod, the second one hollow pipe, the third one also hollow pipe. This one is wickless, this one is having a wick, okay, in which the lower part is connected with the heaters, all 3. They are connected with the heater from where the heat is produced electrically, correct. Next, the upper part is a condenser. Inside this hollow tube, water is filled. As it is weak, it is having wick, so the heat will transfer with the help of the water that is inside this, and it is wickless, okay. So, here again the same thing will happen, but it is wickless. Next, at the top edge we have kept water on this containers, so that a constant temperature must be maintained at the top, correct. So, this is about this pipes. You can see here we are having thermocouples attached at a certain distance that will be ranging from 150 below to 350 at the top side. So, 150 to 350 means in between 200. So, the temperature variation we are going to measure is 200 mm in each of the setup, okay, in each of the pipe. Next, this is our temperature indicator. For that we are having a channel regulator. So, channel 1, 2, 3, 4, 5, 6, 7, 8, total 8 temperatures we are going to get here, okay. Next, this is power indicator. With this regulator we are able to identify that what is the amount of input, power input we are going to give to this our apparatus. These are the switches that will regulate the heater of this all pipes, okay. This is mains, console on, off. So, let us start our setup. So, first of all we need to switch on the mains, okay. Then we need to switch on the tripper, then we need to switch on the console. So, precaution is here, first of all check everything should be switched off, then only we will start our experiment. Before that never try to switch on the mains, okay. So, as you can see they all are at off conditions, correct. So, let us start. First of all mains, next tripper. As you can see from tripper we got the signal that our console is now getting power. Now, we need to switch on this whole panel. So, for that we need to turn this on. Now, here you can see these are the temperature indicators, this is the power indicator, okay. Now, all setup is ready, just we need to now switch on the heaters. So, we can switch on the heater at a time, correct. So, first, second and third, correct. Now, in this we have 6 thermocouples attached with the pipes. So, in which T1, T2 is the temperature surface of the wickless water pipe, okay. Next, T3, T4 it is the temperature surface or temperature of the surface for wick pipe, okay. The third one T5 and T6 on this side, this is the temperature of copper rod, okay, correct. So, let us say right now I have not started the power input. Now, if I start this one, we will get a sound, and as we have turned it on, you see all 3 are switched on. Now, the heaters are getting supply, correct. Now, here we need to maintain certain power input. So, let us say initially we can keep it as 90, okay. So, we need to regulate it carefully So, if the device is okay, exactly we will get at 90, otherwise there might be some plus minus fluctuations, okay, in the power. So, here you can see it is 90. Now, with these channels we can identify the temperatures T1, T2, T3, T4, T5 and T6, correct. So, now what we need to do, we need to wait for certain time so that this temperature that we are getting here will get at steady point. Means right now we have started the heater will start heating, the water is inside the hollow tube. What will happen? The water will attain some temperature and after some time it will become constant. We have to wait up to that point that this temperature will become constant and that is visible here. Earlier it was 33.5 something, now it is 6, 7 and then 8, it will rise up until it is getting steady. So, like that we need to wait for a while, and once it is coming at steady point, just regulate this one to channel 2, channel 3, channel 4, channel 5, channel 6, so that we can get the temperature readings. So, that will be one set. Next set again we need to change the temperature, sorry, we need to change the power input, okay. So, let us suppose after some time when we have taken all the readings, just increase it by certain amount like 10 watts. So, 90 it is, so it will become 100 watts. Again wait for a while and again take the readings. So, like that we have to do our experiment, and once it is over, slowly reduce down the power input, okay. These heaters, switch them off, switch off the console, thereafter switch off the tripper, thereafter switch on the switch off the mains, okay. So, like this our experiment is over. Now, we need to do the observation table. Let us see that one. Now, the calculation part. You see here we need to find out axial heat flux. So, how we are going to get this equation? From the Fourier's law, okay, of heat conduction. So, as per that, Q, that is the heat flux, equals to K, that is the thermal conductivity, and delta T, that is the change in temperature from the heater or the evaporator to the condenser, okay, as we have seen in the diagram or in the setup. Thereafter, this is delta X, that is the length about which we are taking up the temperature or about which we are taking the reading of the temperature. Evaporator at the end of condenser, okay. So, first of all let us see for the copper rod. So, copper rod we had this reading, okay. So, K, value of K is 410. Next 82.4 minus 59.1 by delta X, that was I told from below we need to take 150 and up to when we have to go, up to 350 we have to go. So, you can write it like this, 350 minus 150, okay. Now, solve this one, we will get the value of heat flux. So, the value will be 47.76 watt per meter square. Mm square, sorry, it is in mm, okay. So, this is first reading for copper rod. Similarly, we need to find for the wickless and wick rod, okay. Then thereafter we can compare for particular power supply or heat supply, what is the change in the heat flux. So, same reading you need to take at least 5 observations for different power input, okay. So, like this we can make up the observation table and calculations. Thereafter compare the heat flux on all sets and plot the graph, okay. Thank you.